GitHub can remind themselves how to use GitHub.
Pretty accurate.
Is it up there now? All right, hold on. All right, hold on, wrong channel.
It's mostly because what you guys are doing, and then Randy's in the background like, yeah.
Sorry, this content isn't available right now. I have to log in. And then I can get, oh, there we go. See, look at Randy back there. Oh, hold on.
Oh gosh, look at the accent's face.
That's not you.
Tag him anyway.
Yeah, Haxton's a little creepy there too. Oh, I forgot. I was on Evan's lap. I thought I was on the bottom. So Evan, now we know what's wrong with him. Okay, so let's get our current code base up on GitHub. So I'm gonna create a new repository. Am I currently logged in as me? Let me make sure I'm logged in as me. Yep. So I'll create a new repository. Let's call this CUWOS sim, something like that. And so we'll go ahead and create that repository. Here is the Git for it. Well, actually, I'll just steal these commands. It'll work out well. So let me open up the terminal. And I need to get to the directory where that guy lives. So that's in my Dropbox. Is it in CUW? I don't think it's in CUW. I think it's in my normal Dropbox. There we go, OSM. So we'll do CD, OSM. All right. We probably want to just do this in the source directory. Okay, perfect. So what we'll do is we'll do a git init in here. Then we'll do a git add star.java. And then I need to go ahead and grab my, well, we'll do our first commit as well. Git commit -m initial commit. And then I need to add my remote for this guy. And finally push it. Always allow. All right, and now if I reload this, it should have those files up there. Oh, copy, zigzag, 350, OSM git. Nailed it. All right, so there's the current code base. Do we have an assignment for today?
No.
Really?
We almost got to it, but didn't quite.
What were we doing?
The last thing we added was a note that we need to wrap our queues in a data structure.
Oh yeah. Oh yeah. All right. So, why do we need to do that again? We decided some things are entering queues, some things are leaving queues. We need to be able to find things in queues. So queues need to be able to do a little bit more than just store things, right? So we can either, as what we're doing right now, is we're representing all of our queues as just linked lists. And they're probably still going to be represented as linked lists. But if we need to operate in any of these queues right now, we're going to have to write those specialty functions into Process Scheduler, right? So it maybe makes more sense for us to build a queue data structure, all right, a scheduler queue data structure, and put our linked lists in there, individual linked lists. One will be called the job queue, and so on and so forth. And each of those queues then has some abilities. All right, so we're essentially just going to wrap these guys in that. So let's go ahead and create a new data structure. Okay, notice that the lingo I'm using now, instead of create a new class, I'm saying create a new data structure. I want us to constantly be thinking about our objects as data structures. All right, and what do we want to name this guy? Scheduler queue, process scheduler queue, PSQueue.
P's and Q's.
Sketch DS.
Sketch DS. Is that a PSQueue? Is that it? Process scheduler queue. That's legit. All right, so we'll do that. And this guy is always going to manage a private linked list of PCBs. All right, so all PSQ's job, private link list. Oh, I need to, the queue, there we go. And then we need to import java.util. So all PSQs manage a linked list of PCBs, right? The job queue will manage a linked list of PCBs. The ready queue will manage a linked list of PCBs. The waiting queue or the device queue will manage a list of PCBs. All right, so we probably also want to then have a name for these guys so we can internally remember what kind of queue this is. We'll almost represent its name in two ways. The process scheduler is going to, well, actually, does this guy need to know his name? Probably not. The process scheduler is going to create objects of this type, and let me show you that. So we'll go over to our process scheduler now that we have a simplified version of this. And instead of our job queue being one of these guys, our job queue is actually going to be a PSQueue. Like that. Same thing, our ready queue will be the same thing. It'll be a PSQueue. And so will the waiting queue, PSQueue. Let's just copy this whole thing there. All right, so we've effectively, at this point, wrapped those linked lists inside of a new object called a PSQueue. Make sense? All right, so let's just go ahead and throw a quick comment at the top of PSQueue. We'll say this represents a queue of PCBs managed by the process scheduler. That's what this guy will represent, a single queue. All right, so we need to be able to add things to the queue. All right, so let's go ahead and we're going to say public void add, called add PCB. This guy will take a PCBP as a parameter, and queues will always add it to the end for right now. But we decided last time we might want to add with priority, right? So we might have two versions of this add guy. We'll evolve it as we need to. But right now we'll just always add it to the end of the queue because that's how queues work, right? So we'll say the queue dot add last. And what we'll add is that PCB.
Those add and add last do the same thing, you know?
It's fine. At the very least, we're visually saying we're putting him at the end of the line, right? Okay. So we'll add him to the end. Let's see. Right, we're not going to get one yet. Let's leave that alone. So right now, all we can do is add PCBs to our queue. Okay, we'll add some ability to this guy as we need it. All right, so pretty simple little data structure right now. All he does is wraps a linked list and literally provides an add PCB function that just uses a linked list add last function. Okay, but now we can see we can put other abilities in here that we might need to operate on a queue. So for instance, we might have a public void add PCB with priority. And this guy might take in a PCBP and an int priority. And does something. All right, so just kind of that's where we're maybe going with this. Sometimes you want to put things into a queue with higher priority than other things. All right, but we'll leave that unimplemented for right now. So we'll go back to our process scheduler. We should have some errors now because things that we used to be doing with our job queue no longer do the same thing we did before. So now this thing is called add PCB. So now when we add something to our job queue, we're adding a PCB to that job queue, calling that method, which calls add last on the underlying linked list. Similarly, with the ready queue, we're adding PCB to our ready queue. All right. Now, last time we were mentioning, and this is where those priority things come in, that sometimes, well, certainly when we first double click on an application, we might want that app, that PCB, when it first gets into the queue, we might want it to get up near the front of the line. It should get the CPU soon, right? Because when we double click on Microsoft Word, our main goal in life at that point in time is Word to pop up on the screen. Right? We want it to feel clicky. We don't want him to get to the end of a 20-minute line because you currently have Photoshop rendering something. And Photoshop's got this maximum priority where everything else is super, super sluggish in your machine. We'd like this guy to pop right up. And again, this goes back to this idea that when we're designing operating systems, we're thinking about it from the perspective of, this like balancing act. What's the right threshold so that it feels right, not that it's scientifically right. It has to feel right for the kind of user that's using the machine. That's why we make different decisions if it's a server class kernel or a consumer class kernel. All right, so let's go back and look at our PCB data structure. So right now, a PCB has a PID, a state, a time slice, a parent. It has several different linked lists of stuff, okay, whatever that is. We might decide we're going to create, we did create registers, didn't we? Yeah, linked list of registers up here. Yeah, name and a binary value, good. All right, but a PCB itself does not have a priority. So now we have a question. Does a PCB have its own priority? Or when he gets added to the queue, is he added with a priority? And really to answer that question, we have to decide, is the priority of a PCB a long-term thing, or is it a per add thing? So I'm a PCB, I'm Microsoft Word. You just double-clicked on Microsoft Word on the machine. A PCB was born, that's me. All right, we've already decided that we'd like that guy to be, let's just say, at the very front of the line, the very front of the ready queue, so he gets the CPU next. That may or may not be a true statement, but that's what we're operating on right now. Okay, we're going to put him right at the front of the line. So we're going to talk to the ready queue and say, add with priority, however we decide to represent priorities, right? This guy's important, put him at the front of the line, give him some high level priority. Maybe it's a number 1 to 10, maybe it's 1 to 3, maybe it's 1 to 7, whatever it is. Bigger the number, the higher the priority or something like that. When we say we're going to add that Microsoft Word PCB to the ready queue with a high priority, let's just say 10 for right now. So that's the highest priority in our world, is the priority 10. Does that PCB need to remember that his priority was 10? Or is he just added to the ready queue right then and there, and we put him at the front of the line? Well, we put him at the back of the subline that is all the 10s. So if there's already 3 10s in line, we put him number 4 behind the other 10s because they were all high priority as well, right? So we're going to queue up based on the 10s, let's say. So given that, does the PCB need to know that he's priority 10? Or do we just put him in line behind the other 10s?
I don't think that he needs to know that he's a 10 if he's in a special line.
Okay.
Should it stay in that sub one? Like, so it gets its time with the CPU, but it doesn't finish. Does it go back to the end of the 10 line then? Does it keep its priority until it's finished?
Yeah, what do you think? So Microsoft Word initially has a super high priority, right? Just so we can get the ball rolling. But then his priority potentially could shift as life goes on for that PCB, right? He's maybe not, we minimize Microsoft Word, chances are his priority should shift down from a 10. Maybe he's now a 3 or a 4, you know. It's going to get the CPU, but we're not going to guarantee it's always at the front of the line.
So could we do something where we reassign it a priority, a new priority when it leaves the CPU?
Okay, what priority would we assign it?
I don't know.
Okay, well, so the short answer would be yes, we could. But the question is do we tell the PCB, this is your priority, and then the scheduler asks the PCB, what is your priority? Then we put it into the correct line. Or does the process scheduler make the decision about what a particular process's priority should be?
Could it be dangerous to let the process do it itself? Because then, you know, if I'm creating an application, I just say everything that all my processes are the highest priority, then.
Okay, well, so maybe you misunderstood. So the PCB itself, does he need to hold on to that value? Not does he set it himself, but does
it really matter?
Well, maybe it does. So go ahead and you make your comment, then I'll say something.
I was just going to say it'd be more efficient if only one person knew its priority, because then you wouldn't have to exchange the data between them.
All right, so in a real life scenario, who might be interested in modifying the priority of a PCB? Process scheduler, definitely, right? So this guy is kind of he's the bouncer for the lines that feed into the CPU, right? Who else might be interested in modifying the priority of a PCB? Let's go with the next obvious answer. The user, right? The user might be interested in saying, I want this guy to have the highest priority. You can arbitrarily set the priority. So instead of letting the operating system make the decision for you what it thinks should be important and what shouldn't, you're saying, I want this to be high priority. So now we have the very least 2 people who are interested in possibly adjusting the priority of a PCB. Are there other places in the operating system that we can imagine might work with PCBs that may also have an interest in changing the priority of a PCB? Conceivably, right? Right? So as the user, if I'm changing the priority of a PCB, who do I let know? Do I let the PCB know your new priority is this? Or do I let all of the people that might be interested in changing PCB priority know that I've changed the priority of this guy?
How would them knowing, I would think that the process scheduler is the one in charge of actually feeding these things, right?
Mm-hmm.
So why does any other thing that might want to change it care about that when the process scheduler, I would think that the process scheduler is the only person that would really care about what the actual priority is.
Okay, so really there's 2 options then. We either let the PCB itself know what its priority is, and the process scheduler can grab it from there. Or we let the process scheduler know that we've updated the priority of a certain dude. Look for him in your line.
It seems to make more sense to just have a PCB hold on to it.
It's a data structure. It's a piece of data, right? So we're going to go ahead and add to our PCB the ability to hold on to a priority. All right, which means that we're also going to have to create another class similar to our PCB state, and we're going to create a PCB Priority Class. So let's call this normal is, if we're going to do 1 to 10, we'll say normal is 5. You know, let's actually keep this simple for us. Let's just do 0 to 3. So 0 is low priority. 1 is normal. 2 is high. Let's just do 0 to 2. That's enough for us to. We can imagine that in a more complex operating system, we might want to have a wider range of, you know, is everything the same level of high, or is, you know, in ours, it's, you know, you're either important or not important. All right. Well, in another operating system, you might have, you know, important, very important, really, really, really important, ultra important, so on and so forth. All right, but we'll keep this guy fairly simple. So he has a priority of low, normal, high. And maybe by default, when a PCB is originally created, this is a PCB priority, when a PCB is initially created, let's go ahead and set this dot priority equal to PCB priority dot normal. So we'll default all PCBs to a normal priority and then let them shift from there. Make sense?
When would something go lower in the priority?
When it's in the background. So let's say you minimize Microsoft Word, you know, because keep in mind you're trying to make the end user happy. So when it's minimized, the user's going to notice less that that Microsoft Word's not getting as much CPU time because it's in the background. So we might make it a low priority. Other things that are low priority in our system are going to be things like virus scanning, that type of thing. Even though we perceive that to be a high priority type task, it's low priority on the CPU because we don't want our machine to feel sluggish because we're constantly scanning for viruses. We want it to have kind of a constant low noise situation in the background where every single time it gets an opportunity on the CPU, and we've said the CPU is not busy 95% of the time, right? It's idle 95% of the time. So that means that we can do a whole lot of virus scanning in a low priority situation. So we're not like starving it out. But we don't want it to take over our system when we are trying to do things.
So you talked about minimizing, but is it similar with running multiple desktops, where you can switch between desktops?
Well, I think possibly. I mean, I think it is similar. So multiple desktops is kind of like minimizing all of the active applications on a desktop you're not sitting on. So probably a similar type of decision making. If I'm not looking at the desktop, so I'm not looking at this guy right here, so he shouldn't be getting a whole lot of CPU time. We should look at that picture again. You know, just why we're here. There we go, Randy. Look at that. Although Nick that's problematic as well.
And then Haxton's looking.
Actually, that's kind of par for the course for Haxton, I think.
Oh God.
The bad thing is I was so tired, I thought I was in the bathroom. So, bad news for Evan, for Beyonce. All right. So, we'll start off every PCB as having a normal priority. Okay? Go back to our process scheduler. Uh-oh.
You probably just have to say that.
All right. So now we're adding things to our queue initially. Now, when a process is first born, when we're first creating a PCB, the PCB is born, but we are going to, the process scheduler here who has created that PCB is going to artificially increase its priority. All right, so we'll add the new PCB to the queue, but then we're going to go ahead and we're going to actually, before we do that, we probably want to say this dot, sorry, not this dot, just the new PCB. The new PCB dot, and let's go ahead and give him the ability to set his priority high, set his priority low, set his priority normal. All right, so let's go into our PCB and give a couple of functions, similar to what we did here. So public void set priority high, and this will say this dot priority is equal to PCB underscore priority dot high. Set priority normal. And set priority low. All right, so just a couple of accessor functions that allow us to wrap our priority private field inside of our PCB. Now, the reason we do it like this is so that we don't need our external people to know how priorities are represented. Right? That process scheduler, he doesn't need to know that we've represented our priorities inside of this data structure. All he needs to know is to tell a PCB to set your priority to a certain thing, whatever that means. Okay? You there, high priority. You there, low priority, so on and so forth. Make sense? Just do whatever that takes. All right, so that's our PCB. So back to our process scheduler. After we've created the PCB, but before we add it to the job queue, we're going to go ahead and say the new PCB dot the new, oh, new is all lowercase, dot set priority high. All right, then we're going to go ahead and add him to our job queue. So we'll do add PCB. Now the reality here is we probably want our job queue to always take priority into consideration, right? So right now inside of our job queue, inside of our queue, we kind of have prototyped a second method that says add it with priority. Go ahead.
Does our job queue need to do that, or our ready queue need to do that?
Well, our job queue really is blind to priority, right? Because it's just a collection of things, of all the processes. So it's blind. It's blind to probably blonde as well. It's blind to priority. So we can say that this is the version of the method that doesn't even think about priority. So we might call that on our job queue. And then this is the version of the method that we'll probably call most of the time when we're dealing with the ready or the waiting queue that thinks about priority, right? All right. So this guy's going to take in the PCB we're adding, but he's not going to take in a priority because the PCB has the priority, right? So now we have an issue. What is it called when we have two methods? Well, here, let's back off here real quick. Okay, two methods with the same name but a different number and or type of parameters. Polymorphism. All right, so the idea here is, though, that we have a method that takes in a single PCB and we have another method that takes in a single PCB. We can either change the name of the method, assuming it'll add it based on priority, or we can add a second variable to our method, whether or not to consider priority. So maybe this is with priority of type Boolean. Something like that. So maybe we have a single method where we add a PCB. Here's the PCB we're adding. And then we tell it whether or not to include priority, either a true or false. So then we say if not with priority, then we'll just add it to the end. Otherwise, add with priority. Fair enough? All right, so when we go back into our process scheduler now, we set the priority to high. We're calling our add PCB to the job queue. When we add it to the job queue, are we adding it with priority? No. False. Add it to the job queue. Don't consider priority. But, so that's added it to the, we've added it to the job queue. Then when we get down here, we set its state to ready. This is after we've set its priority to high, let's say. Then we're going to add it to the ready queue. And we do want it to take into consideration priority. Make sense? All right, so so we've kind of written the method once and called it two different ways. Probably safer to do that than to have two separate methods, because somebody might stumble upon one of the methods before they stumble upon the other and assume it is adding with priority or adding without priority. You know, if they say, oh, I'm adding it to the queue, so it must just take priority into consideration. Well, now, every single time they call the add method, we are forcing them to specify, should we take priority into consideration or not? Make sense? All right. Okay, so now we got to go back to our PSQueue and think about how do we handle priority. So when we add something with priority, what does that mean? Right now we have 3 priorities, right? 3 different priorities. And at some point we're going to have to remember that in our okay, well, how do we know what that priority of the queue is? So this gets back to this idea of a data structure, right? Remember we talked before about a heap? Heap acts like a priority queue. So internally in here, we're going to have to create a data structure for representing our various lists of PCBs. How would you implement this? Because I'm going to have some PCBs in the ready queue. For example, let's assume we're sitting in here, we're an instance of the ready queue right now. We're going to have some PCBs that are what? High, low, and normal.
So 3 lines.
Oh, we can have 3 separate lines. So depending on what their priority is, we add them to the correct line. What do we do for something like the job queue where there's only 1 line? End of what? Which line?
It just doesn't matter.
Well, I mean, it matters a little bit.
Couldn't there be
We got to make sure we add them to the same line.
Isn't there only 1 line though?
Well, there is right now. He's suggesting 3 lines.
Couldn't you have 3 lines in the ready queue, which is a different queue?
Well, right, but they're all instances of PSQ.
So have the queue, have the high queue, the mid queue, the low queue, and then have 4, and then your 4th line is just your job queue. All of them.
Okay, so now you're making this generic data structure specialized for the job queue.
Well, I mean, we could either just use this or have a PS ready queue and a PS job queue,
Okay.
and then the ready queue is just
How are we going to use the PSQ that's associated with our job queue?
In order to fill our other queues.
Are we ever going to feed off of it based on priority? No. So when we're adding something to our queue without priority, so that's with, not priority, as long as we always add it to the same queue, maybe we just decide we're going to use the normal line as the default line, right? As long as we're always adding it to that, when we remove something based on not priority, then we'll just remove it from that normal line, rather than make this thing special for our job queue. Because we might have other uses for job-like queues, right? But now you suggested we have 3 different lines, right? Okay, how would you represent 3 different lines? 3 different linked lists? So instead of just having something called the queue, we might have something called the low queue, the normal queue, and the high queue. So keep 3 separate lines here. Now we happen to know that we are representing our, where is it in PCB? Our priority as numbers. Could we create a linked list of queues indexed by their priority? But that assumes that we'll always represent our priority as numbers, where this could change potentially, right? That's the whole reason putting this in, that we put this into its own data structure. But the alternative is right now we've assumed there's only 3 by creating 3 lines. So if I create a 4th priority here, what do I need to go and do? Create a 4th line. Okay. In software engineering terms, what is this term? What's the term that references these 2 guys being dependent on each other?
Be dynamic. Be able to dynamically grow.
Well, that's what it needs to be able to do. But what's the software engineering term that talks about 2 things that are reliant on each other?
Codependent?
Okay, it's called coupling. Have you heard of that? Did you hear about that in the class?
No.
Okay. Levi, who doesn't pay attention, thinks he did.
You're making us all look bad.
He's deep in a StarCraft game back there. I'm being attacked on 3 different fronts. All right, so do you play StarCraft? Oh, so it was a bad guess. What games do you play?
Hearthstone.
Oh, you play Hearthstone. Oh, yeah, so do I. I cheat at Hearthstone. I don't cheat at Hearthstone now. No, I don't bot Hearthstone anymore. That account got banned.
They killed Grim Patron.
Really?
Yeah, they nerfed Warsong Commander. Just beat it. It's now 3 cost 2/3 that just gives your charge minions.
What does Grim Patron do? Now,
Grim Patron.
I know he was the one that if he takes damage, he
No,
duplicates.
the Grim Patron deck they destroyed.
Oh,
All they did was they took Warsong Commander and changed it from your minions with 3 less attack have charge to your charge minions have +1 attack.
I see.
So they just made it a shittier raid leader.
I gotcha.
It's the best day ever.
I still don't like that Grim Patron. You can't do
I was
3.
just about to build a Grim Patron deck when they nerfed it. It's like, oh.
I use him. I have 2 of them in one of my decks. I use him to attack 1/1s.
Yeah.
And it's just like summoning another minion. I know. All right, what was I talking about? Oh, coupling. So we have a situation here where we have one data structure, our PCB priority, which is coupled with another data structure, which is our PCB, I guess to some extent, right? Which is also coupled to another data structure, which is our PSQueue. So now let me ask you this. Is it always possible to get rid of coupling? I mean, in our ideal world, when we talk about writing objects, in our ideal world, we'd like things to never be coupled. That way we have complete autonomy on every one of our objects to make any choices that we want to make, as long as the inputs remain the same, remain consistent, and our outputs remain consistent. Because the second we change the inputs we expect, we have to go change something else, right? There's coupling involved there. But as long as it's a self-contained machine, think about an engine. You drop an engine into something that needs an engine. As long as you hook up the thing that spins to the right place, the car, for example, doesn't care how the engine works, just that it puts out power, correct? That the power head spins. So in this particular case, can we avoid the coupling here? Let's say maybe. But would you agree with the term that we can't, with the idea that we can't always avoid coupling, right? There's going to be some level of coupling. So the real question is do we try to go to great lengths to avoid coupling, or do we minimize coupling, where if we have 2 or 3 objects that are relying on each other, that's okay, changing one breaks the other 2, but doesn't break 50 objects across your operating system. Fair enough?
Wait, so is coupling bad?
I don't know. Coupling is probably more bad than it is good. And it's software engineering, it's not an operating system term, it's a software engineering term. So coupling is when we have a data structure that's reliant on another data structure. So changing one breaks another one, or modifies how you have to approach the other one. So I don't think coupling is inherently bad, but it's certainly something we should attempt to minimize. But just because you have coupling, just because coupling exists in your application, doesn't mean your application is inherently bad. All right, so having said that, would it be okay for us to create a private linked list of linked lists of PCBs? So I wonder if it's going to let me do this. Will generics do that? Call this guy the queues. This is a new linked list of type linked list of PCBs. So the type of value that this linked list is holding is not a PCB, not a PSQueue. He's holding a linked list of PCBs. Which means then we can have a constructor in here, public PSQueue. And this constructor maybe sets the queues dot add. And we want to add to the end. So we're going to add the low queue first. This dot the low queue. Then the queues dot add this dot the normal queue. Then the queues dot add this dot the high queue. So now I have a linked list. So this adds low queue to position 0, or we can think of that as position, what do we call it? PCB underscore priority dot low. This guy adds to position 1, or PCB dot priority dot, or PCB underscore priority dot normal. This guy adds to position 2, or PCB priority dot high. Make sense? So I've created a linked list that says add crap. Well, I've created a linked list of my linked list, and I just happen to put my low queue at bucket 0 of the queues, my normal queue at bucket 1 of the queues, my high queue at bucket 2 of the queues. So now, when I add without priority, what am I going to do? I'm going to say the queues at position. Let me just do this real quick. Oh, it's called the queues dot. I know we're out of time, so let me just give you enough to do your homework. At position PCB underscore priority dot low, or actually let's say normal for this one, dot add, we'll add to the end of the line, P. So for your homework, implement the else here, add with priority. Okay? If you have followed what we've talked about today, your implementation is one line. So if we're not adding with priority, we just add it to the normal bucket at position last. Otherwise, if we are adding with priority, your homework is to just write this else. Could be one line. All right, I'll go ahead and push this up to GitHub and put the link into the homework assignment and just say to write the else in add PCB of PSQueue. Sound good? All right, I will see everybody on Friday. Midterm would be during midterms week. When's that?
Next week.
So I usually do it the week after, so probably the week after. Will we come back from fall break? Because you'll have a lot of midterms during next week, I'm guessing, right? Is that a true statement?
Not too many.
I'll think about it. It'll either be next Wednesday or the Monday after break. Or the Wednesday after break.